Good morning, good afternoon, and good evening, and welcome to the Friday talk show of Global Electronics with your host Rajiv Kulkarni. The time is 8 o'clock in the morning, Central Standard Time of United States, and 7:30 p.m. in India. That is IST, we call it. So today's date is February 27th. We are almost now one day shy of finishing 2 months of 2026. Already 2 months have gone of 2026. And we are getting into March 1st on this Sunday. And the main objective of Global Electronics show every Friday is to bring wealth of knowledge from our expertise who are technology experts in their various field in the electronics manufacturing. And just to remind you that this is only focusing on the electronics manufacturing, whether it can be related to design, whether it can be related to the quality, testing, or the processes, or the market intelligence, or the supply chain. Anything and everything that relates to electronics manufacturing on a global basis. And I really thank all the audience out there who watch our show, even though not a live show, but they do watch later. And then that increases the subscription, as well as also by increasing the subscribers, definitely the viewership increases. So please do subscribe if you have not done yet, and please also share the link of the channel with your colleagues and the friends in the electronics community. So we try to bring in the knowledge, the topics every week, some different topics, and some of the topics are so vast that it cannot be finished in 30 to 40 minutes of our show, and we have to divide that into different episodes, and definitely it makes interesting, and also we try to cover as much as information. If you have any specific topic that you would like to address in the electronics manufacturing, you can write to us, you can send your contact to us, so we'll contact you so you can be also part of the show. So let's start today's show, and first of all I thank all the guests who agreed to participate, and I thank all the audience, and I thank Mr. Sandeep of A&V Perspective, who is based in Bangalore and who helps in technical backup and supports me in getting all the scenes and everything ready. Thank you. And then let's start our show of today's Friday talk show with your host Rajiv Kulkarni, February 27th 2026. Today we have a very special topic, and it's a very vast topic as well, because you have to have that in order to have a very smooth flow of production and manufacturing in the electronics, or maybe in any production or manufacturing, I would say. It's a Statistical Process Control. In short, it is called as SPC. It's a very important factor in the electronics manufacturing processes. It ensures process stability and product quality. Common applications can be, component placement, accuracy, soldering processes, and testing of PCBs, and so on and so forth. We have expertise to discuss that today with us, Mr. ANILRAJ, who is a technology expert, who is also heading the engineering and capital equipment division in SF4 Technology, which is a part of Nest Group, and it is based in southern part of India, the state called Kerala state, and the place where this company belongs to is in Cochin. That's a beautiful city out in southern part of Kerala, and basically SF4 Technologies are the part of Nest Group. What they do is they started as an EMS company, as standalone electronics manufacturing company, but they over a period of time they developed so very well, catering into different market segments, whether it is aerospace, whether it is aviation, whether it's defense, or medical electronics or automotive, or name the field, telecom, they are into that, and they are very, very well vertically integrated. I mean, they have the ODM capability, they have system integration, they also do the software integration, and so on and so forth. So today we have Mr. Anil Raj. Welcome to the show, Mr. Anil, and good evening to you. How are you this evening?
It's doing good.
Very nice, very nice. I know that the state that you live in, Kerala, it is supposedly one of the beautiful state now in India because of the weather, because of the scenic beauty, and and also you are based in a place called Cochin, that itself is a beautiful city. And I sometimes wonder, you really feel like working when you have so much beautiful, scenic surrounding you, and and you are like buried in the electronics day in day out. So thank you anyway. I know that you have a busy schedule always, but you take out your time and you share your wealth of knowledge with our audience, with our people, and with the electronics community out there. Thank you for doing that. Really appreciate that. So, Mr. Anil, can you just briefly tell about your role, where you're working, and then we'll start our interactive session for today?
All right. Yeah. So, good morning and good evening to all. As he mentioned, I am ANILRAJ, heading process and equipment engineering at SFO Technology. So, SFO operates under NES Group, a company based in the as you mentioned, the southern part of India called Kerala. This was established in 1990. Provide total ODM plus solution to diverse industries such as aerospace and defense, communication, energy, industrial, healthcare, and transportation. So mainly, I am looking the basically mainly for the process and equipment selection for the different process involved in the aerospace and defense industry. Then process qualification, process optimization. So you know that so many customer audits will be there. We need to meet their regulatory standards or IPC standards. We need to meet that. So all the qualification process should need to be in line with these standards and the customer requirement. So here, thank you for giving me this opportunity to speak
Absolutely.
a critical topic
Absolutely.
like statistical process control. Since you know that as
Okay.
you the vast subject, so we can cover a small.
Sure, sure, absolutely. So, Anil sir, so let's start our interactive session for today. And what exactly is SPC, and what is the importance of SPC and its background?
All right. So you know they say that statistical process control. It's a method for monitoring, controlling, and improving process by using statistical technique to analyze the data collected over a time. So this SPC helps to ensure the consistent quality and reduce defects by distinguish between the natural expected variation. We call it as common cause and unusual variations. That is a special cause where it requires some corrections. Hence, this primary goal of SPC is to minimize the process variations, leading to greater efficiency, less wastage, and more predictable results. So, before going in detail with the statistical process control, I think most of them are aware of the statistics, the term called statistics. The statistics is a mathematical branch of mathematics. It's
Yes.
Yeah, it is a practice of collecting, the organizing, analyzing, and interpreting numerical data to understand the patterns, and from that draw conclusions and to make some decisions. So this tool provide to quantify uncertainty and to make inference about a large group based on a small samples. So the statistical process kind of the name itself is a statistical process and control. Statistical means deals with the collection of data, and the process means transform the input to the desired output, and the control means maintain the system or policies or procedures to maintain the consistency in the manufacturing process. So this is in detail about the statistical process control SPC.
Okay, great, great. So, what is actually the common causes or the special causes for the SPC?
Yeah, that's another point I said that the common cause, there are two variations. One is common cause variation and the other one is special cause variation.
Mm-hmm.
The common cause variation is the natural variations, that is inherent variation that always present in a stable process. But assignable cause means it's a temporary. We cannot predict that. It's an unpredictable variation that arises from a specific identifiable event or source. I can give an example. So
Yes,
normally here the since it's a manufacturing company, the normally the shift start at 8:30 a.m. Right.
right.
So if you plot the arrival of the employees here, it could be 8:20 a.m., 8:21 a.m., or 8:34 or 8, sometimes it will be 8:15, like that. So this variations happens by chance. All right, this variation. This is called a common cause variation. This is called common cause. But for example, one day there was a roadblock at certain locations, and the employees, instead of coming at 8:30, they came here at 10:30 a.m.
Mm.
So called specific cause or assignable cause. So the SPC chart, normally SPC chart helps to differentiate this assignable cause from a common cause. So these are the main two critical points in the statistical process control: common cause and assignable cause.
Okay, great, great. So, what kind of steps are involved in SPC?
There are multiple steps involved in the statistical process control. Commonly, there are 6 steps. One is, so first we need to define our objective. That's a critical point. So where we need to start SPC, statistical process control. So identify the area, the critical area. Critical in the sense, some cases, customer will say that this is a critical to quality point. So that area, we need to take it as mainly for the statistical process control. That's the first one, define the objectives. The second one is purely, as I said earlier, this purely a data analysis method. So
Correct.
we need to identify a better data collection method. We need to identify that. Then we need to select the SPC chart. If there are different SPC charts available, that's why I said I'd say in detail. If you go in detail, there are so many charts are available. So we need to select the
Yeah.
chart required for that particular stage.
Right.
Then once the chart is defined, we do establish the control limit. Control limit means there will be an upper control limit and lower control limit. Then we need to collect the data, populate the data, and if the data is go beyond the control limits, then there will be a variation. Then in that case, we need to monitor this and we need to analyze the cause for the variation. That is the another step. The finally implement and evaluate improvements. Finally, so because of this variation, we need to identify the root cause, take some corrective action, implement it in the line, then evaluate the performance. Improvements we need to evaluate that. So there are 6 steps. One is define your objective. Objective need to be defined. Then data collection. Second one is define the proper data collection method. Third one is select the suitable SPC chart. Fourth one, define the control limit. Fifth one, monitor and analyze the process. Last one, implement and evaluate the improvements based on the implementation of the statistical process chart. These are the 6 steps which is involved in the statistical method.
Wow. That's very interesting steps, because no wonder it brings the name as a statistical process control, with the collection of data.
a beautiful tool to identify the exact cause variations can be beautifully, we can identify that. And if we follow the exact steps in this, definitely all the variations can be properly addressed and we can maintain a stable process of time.
Okay, wonderful. So, what kind of, I believe there are around 7 quality tools engaged in SPC or supporting the SPC. What are those?
Yes. So normally, this is to the seven quality. If you contrast is a quality control tools. That is mainly to identify uh, the root cause of the failure or how this can be rectified. Everything can be done in this. So this tool was popularized by Ishikawa, a Japanese quality management expert,
Okay.
and is widely used in the industry to identify and analyze and improve the quality related issues. So as you said, this is correct. There are several quality areas. One is called cause and effect diagram. Cause and effect diagram, it is called a Ishikawa diagram or fishbone diagram. Normally, to identify the root cause, most of the companies or organizations are using the cause and effect diagram. So the cause and effect diagram identify the root cause of a problem, facilitating the effective problem solving method. Here, it's like I think all of you are aware of this. It's like a fishbone structure. That's why it's called a fishbone diagram. And where the head represents the problem and its bone represents various categories of cause, such as it can be machine, material, method, or mother nature. That can be clearly identified with the cause and effect diagram. The second one is check sheet. Check sheet is a structured form used to collect the data in real time at the locations where the data is generated. It is normally useful for repetitive data collection and enables easy categorization of the observations. So normally the application point of view, it is used for recording the frequency of defects, type of errors, and process related events over a time. For this, the check sheet is used. That's the second one. Third one is, as I mentioned earlier, the control chart. Control chart is used to monitor the process performance and variability over a time. So when we do the control chart, the chart includes a center line which represents the average of the total data collected. Then there will be an upper limit control limit and a lower control limit. So the data points plotted in the chart helps to identify any variation from the process standards. So this is useful to monitor the production process to ensure that it is stay within the control limit or any commonly used manufacturing issues that can be clearly identified with the control chart. The fourth one is a histogram. Histogram is a bar graph that represents the distribution of data over different ranges. It helps visualize the frequency of data points within a specified intervals. Showing the shape of the data distribution itself, we can clearly identify the exact root cause of this. That is called a histogram. Then next one is Pareto chart. Pareto chart is also a commonly QC tools. Normally, it based on the Pareto principle. That is, Pareto principle means 80-20 rule, which states 80% of the problems are often caused by 20% of the cause. That's the 80-20 principle. All right. So the chart displays bars in descending order, and with the most significant factors on the left, and the line graph representing the cumulative percentage. So it is mainly ideal for prioritizing the problems or causes to address the most significant issues first. So instead of going for the entire failure, we can categorize this into 80-20 principle, and we can take the actions for the first cause of issues. Then scatter diagram. Scatter diagram plots the data points on a graph. to show the relationship between the two variables. Wherever there is a variable, then if you want to correlate between the two variables, then it is better to use the scatter diagram. If the pattern indicates a clear relationship, it is a positive, negative, or no correlation, it can go to after analysis. Then the final one is
Okay.
stratification means it is a sorting of data into subgroup. From the main group, the data can
Yeah.
go into subgroup based on the characteristics like location, time, or method for analyzing them separately.
Yes.
There are seven different QC tools associated with the statistical process control. I think most
Okay.
of the companies
Excellent.
are using
Excellent.
Purple chart and the fishbone diagram because it's a part of AT also. Whenever there's a failure comes, then we need to identify the root cause and the corrective action we need to give that. For this, the cause and effect and this one, Pareto is the main tool which is used in the most of the industries. It's called,
Fantastic. Yeah. Go ahead.
so that's
Yeah.
why it was defined by a Japanese quality management expert called Ishikawa.
Ishikawa. Okay. So it's basically Ishikawa's, I would say, tools, quality tools to in order
Yes.
to support the SPC. And what kind of different control charts are available?
Yes. The control chart that depends on the type of the data which we have collected. The different control charts. Primary,
Okay.
that's the primary SPC tools actually. I can say that. So there are various variable control chart. Variable control chart means for the continuous data. So
Yes.
we can use variable control chart. The
Yeah.
common variable control charts are X bar R chart. One is X bar R chart. Then X bar R chart means X is the average of the data collected, and R is basically the difference range, the difference between the
Hmm.
two. If the population, if we have taken a population from this, if we take the subgroups, and if the subgroups is in between lesser than 10, then we can go for X bar R chart. The second, another one is X bar S chart, where S denotes standard deviation. Standard deviation is, that's again a variation between the two values. So this X
Yeah.
bar,
I was coming to that question as well. What is standard deviation? So anyway,
yes.
yeah, please go ahead.
Okay.
Yeah.
Okay. Then there's a individual and moving range chart, IMR chart or MR chart. That will also, if you want to plot it for a single piece, then whether the subgroups is not possible. In that case, we can go with the IMR chart or XMR chart. Then for the dispersion, for the continuous variation, we can use R chart, that is a more range chart, S chart, standard deviation chart, or MR chart, that's a moving range chart. So
Wow.
these are the charts mainly for the variable data. If the data is attributable data, then we need to go for P chart. That is a proportion defective chart. In that case, the sample size will varies.
Hmm.
Then NP chart called a number defective chart. Here the sample size is constant. Then if you want to measure it on a defects per unit, then we can go for C chart. That's a constant area, we can go for a C chart. Or if it is a varying area, we can go for U chart. So that's a depends on how we need to analyze the data. We can take these charts like X bar R chart or SPARS chart, IMR chart, NP chart, P chart, C chart. This purely depends on the different type of uh, 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 data method which we are collecting. I can show one slide which
Yeah.
give a idea on how the control charts can be selected. I can show that now.
Yes, please. Yes, please. I think I have. Yeah, you can share. I have given the. Yes.
I think this is the control chart.
Control chart. Yeah.
Yes. So if it is a let's if it's a attributed whether determine the data type. If it's an attribute or variable, if it's a variable one and sample size one, go for IMR chart. If it is the multiple data, sample size, if more than one, sample size is less than, go for X bar R chart. If it is no, go for X bar S chart. Attribute if it's a defects or defective units. Defects, go for a U chart or C chart. Samples, if it is a defectives, then go for P chart or NP chart. This is the way the method for selecting the different control charts.
Excellent. So what do you actually mean by mean, median, and mode in SPC?
So mean, median, and mode. That is basically the mean means it's average. Normally, it's an average.
Right. Okay.
So when we take some data, when we take data, and if we take the average of this, normally it will comes when we calculate the equations of this. It will comes over here. And hope I have stopped share this, right?
Sorry, say that again.
I think it is shared. Do I need to share?
No, you don't. I mean, it's up to you. If you want to share, that's fine. If not, that's also fine. It's totally up to you. You can verbally say also. No, no worries.
Okay, right. Okay, right. So the mean in the sense, it's a mean is calculated by adding the values in the data set and divided by the number of values. That's the average. Normally we will take it. And median in the sense, median is the middle value of the data set. When the values are arranged in ascending order. The values are arranged in ascending order. The middle value is the median. If you take the median, then if it comes in the even number, then the median is the average of the two middle values. That's the median.
Okay. Okay.
And
Wonderful.
mode is the value that appears most frequently in the data set.
Okay.
The data set
So
may have one mode or more than one mode. Sometimes there will not be any mode at all. If there is no repetition in the values, the data set, then
yeah.
there will not be any mode of this.
Sure. Sure. So what exactly is standard deviation in that case?
Yes. The standard deviation in the statistical measures normally quantifies the amount of variation or the dispersion in a set of values. That's that's mainly the statistical measures. So the standard deviation indicates how much the individual data points deviated from the mean, which we have discussed, mean or average of the data set. So a low standard deviation means the data points are close to the mean, while a high standard deviation indicates that the data points are spread or a wide range. So it purely gives the variations in the data which is collected. So normally in the statistical process control, there will be a group of data. Then from the group of this particular data, we'll be calculating the standard deviation. How this can be done? For this, there are following steps. First, as we mentioned earlier, we need to calculate the mean. Mean of the data set need to be calculated, first of all.
Right. Right.
Then subtract the mean from each data point and square the result. That means we need to first calculate the mean value, then subtract it from each data point and square it. Then again, mean of the square differences. Then take the square root of this. That will give the standard deviation.
Standard deviation.
This is
Okay.
the average of the variations which is which is coming from the mean value. So this is
Wonderful.
the way to calculate this. Salary.
So, what exactly is process capability analysis?
Process capability. Once that's why, as I said, that we have so many control charts. The first of all, so we have so many control charts on the once the process. If we ensure that the process is stable
Hmm.
by if the values are within that particular limit, then we can go for the process capability. So a process capability study uses the data from the initial run of the parts to predict whether the manufacturing process can repeatedly produce the part that meet the specification. So what we can do is we can take some historical data and
Right.
extract out to the future to answer the question like, can I rely on this process to deliver a good part? That is process capability. Take the
Hmm.
historical, extrapolate it to the future to get that if we can rely on that particular process to deliver a good part, then definitely it's that's a process capability. So
Hmm.
when the manufacturing process is being defined, our goal is that the parts produced fall within the upper and lower specification limit that is defined by the designer. So this process capability measures how consistently a manufacturing process can produce the part within the specification. That is process capability. To
Wow.
how we can ensure this, there are two methods. One, CP and CPK, the process capability index and the process capability index method. That can be calculated. From this, we can say that our process is stable. So the basic idea is very simple. If we want to have a manufacturing process to be centered over the nominal value decided by the designer of engineer, that we need to centered
Hmm.
over the nominal value. That's the first requirement. The second requirement is the spread is narrower than the specification width. So this CP and CPK, there are two critical indices will give the measurement of that. That means
Yeah.
this will give the specification width by the process width, which gives whether the process spread is narrower than the specification width. CPK will
Hmm.
give CPK calculate how the CPK is calculated like distance from the mean to the nearest specification width divided by the distance from mean to the process ends, which will give the measure of centering of the process as well as the spread of the process related to the specification width. If it meets, we can say that the process is stable and we can follow the process capability process over there. I can
Hmm.
give an example
Yes,
to give a
please.
clear idea on this. Imagine a driver trying to park a car in a garage. So if assume that if the car is too wide, it won't fit into the garage. If that means if it is narrower than the garage opening, but if it is not centered, it won't make into the garage. It will likely hit or scrap one of the sides.
Sides.
Right?
Yeah.
Right. Hitting one of the side of the garage is equivalent to produce a defective part in our case.
Okay.
But assume that if the car is narrow enough and well centered, it is well centered and narrow enough, the car will fit into the garage. This is our goal. We want to manufacture the process width that is narrow and well centered to the specification width. In some cases, now let us assume that the car is having the right width, it is narrow enough and should always fit into the garage, but it is now up to the driver's skill to park without scraping the sides. Correct.
Yeah.
Imagine a driver arriving home after the work each day and parking his car in the garage. A good driver will always center the car well with enough room on both sides.
Right.
Over the next 20 days, if you run the Panto chart or sorry, run chart or histogram, so we can from that we can clearly say that it is unlikely to scrap or dent the car because there is plenty of room on either sides.
Correct.
In other case, if there is an unsteady driver or someone learning to drive, may not always center to the car correctly, right? Over the
Yeah.
next 10 days, if we take the run chart or histogram, then we can say that there will be a variation. That means it is very likely that he could scrap or dent the car. So this is the way manufacturing process is centered to the mean, and the variations will be narrowed down to get a stable result from the manufacturing process. This is taken through this process capability analysis.
Capability. Wow. Very interesting and very informative as well. The garage example was great. So final question I have for you, Anil sir, is what is gauge R and R?
Okay. Nature under is an important aspect in the SPC, right? So this SPC chart and capability studies rely on, as I said, that measurement data. If the measurement data is true, then from the analysis we can get the real outcome, right? So if
Yeah.
assume that the measurement data system is bad, then our SPC chart will not give a real outcome from this. So some cases, the real process change may be hidden. Noise from the measurement error mimics the process variation. To avoid this, gauge R&R, that is gauge repeatability and reproducibility. It is a methodology used to define the amount of variations in the measurement data due to the measurement system. So it will define the amount of variations in the measurement data due to the measurement system. It then compares the measurement variation to the total variability observed. Then we can define, consequently, we can define the capability of the measurement system. So the measurement variation have two critical factors. One is repeatability and reproducibility. What is repeatability, reproducibility? Repeatability is due to the equipment variation, and the reproducibility is due to the inspector or the operator variation.
Okay.
So if the repeatability and reproducibility is within that particular certain range, then we can say that the measurement system is giving a consistent result. With this, we can go for a statistical process control methodology.
Okay. Excellent, Mr. Anil. And I think we are almost through the time that we specify normally. 30
Okay.
to 40 minutes of our show, and these are some of the questions which were answered very effectively, and I hope all our audience would enjoy watching that at a later stage. So the SPC is such a vast subject. Probably we can still continue as an episode 2 pertaining to this thing in the coming days after we check your availability and what time suits, because you have a very busy schedule always. And but I should thank you very much for coming to the show today and sharing your experienced knowledge to the electronics community out there, and to all the audience out there and all the people who will watch this at the later stage. If you have any questions, please do comment on the comment section without any issue, without any problems. And last question, Anil sir, is of course SPC is definitely a need without which no quality can be passed through, right? And yeah, I mean if we look at all the standards in the industry, ISO standards or automotive qualification and all these things, So SPC is one of the main thing those auditors will always look for, and so it applies to whether aviation, whether it is automotive, or whether it is medical. But anything that you produce, manufacture, SPC is definitely a vital process capability that you need to implement. So Anil sir, any last message you want to give before we say sign off for today's show to the people?
Anyway, all of them are experts in this particular process, right? So it is better to so we need to maintain. So wherever there is a critical stages in the manufacturing age, or if there is a critical to quality requirements for certain products, then where it is better to implement the SPC. It's very difficult to maintain SPC. Why? Because so normally all of them are looking for if the product specification is within that specification limit, then this can be accepted. But so this will give a more advantage over a time to ensure the reliability of the product and getting better advantage on the product in the sense of quality. So that is better to follow wherever possible in the manufacturing line. Is better to follow the statistical process control.
Thank you very much for this wonderful message, and I should thank all the audience out there. Have a wonderful weekend, and wherever and whichever part of the world you are. And thank you for watching. And we will come back next week with yet another new topic, or maybe we might, if Anil sir is available, we might continue with another episode of SPC. And but you will know that once we determine the poster as well as the YouTube link. With that said, please take care of yourself. You be healthy, and keep watching Global Electronics, and keep sharing our channel and subscribe the channel. And thank you all. Thank you, and God bless. Bye. Bye now.